Let's go ahead and go over example 2 under 1.3 piecewise defined functions. So here we have a piecewise defined function. We have 3 different rules, and here's the domain for each of the rules. Don't forget, this is your domain. These are the intervals of x values that you can input into each rule, into each function, in order to get those outputs that are going to create the graph. Now let's also remember, if you have a closed dot, that means the value is included, so you would have an equal sign in your inequality. If it is an open dot, the value is not included. You would have inequality such that less than or greater than. So now let's take a look at what we got here. Now I can see this one is linear, and I know that it only takes 2 points to graph a linear function. I can also see that I'm going to have a closed dot and an open dot based on these inequalities. So what I'm going to do is, if this is linear, these are going to give me the endpoints of this graph. So we're going to sketch that graph of my first line for values of x between -10 and -2. I only need to do 2 here because these are going to give me the endpoints. That's all I need. So we're going to have f of -10 equals, and again I'm grabbing my first function, 4 times -10 plus 11. Well, that's going to be -40 plus 11 is a -29. Which means now I have the ordered pair -10, -29. And now let's grab the end of the domain. That's going to give me the other endpoint, -2. So f of -2 equals 4 times -2 plus 11. Well, 4 times -2 is a -8. Plus 11 gets me a +3. So that gives me the endpoint of -2, 3. These are your endpoints of that graph, and I can just use these to graph. So come down here. This is already graphed for you, but let's just talk about it. So -10, 29, that's down here. And notice too, it's a closed dot because my inequality had that equal sign. It includes those values. Now up here is where my -2, 3 is. And it was an open dot. And notice it's kind of filled in with the blue. That's my second function, and we're going to get to that soon. But you would just graph these and then of course draw your line. So that would be one piece of the piecewise defined function done. Now let's look at the second line. I can see that this is a quadratic. I'm going to need more than 2 points to graph a quadratic because I know it's going to have like a dip. It's going to be like either a U that goes a U or an upside down U, excuse me. So again, I can tell I'm going to be using closed dots. And now let's go ahead and find some points on that graph. And I'm going to use my domain. -2, I'll always use the endpoints of my domain. So I get -2 squared minus 1 equals, well, -2 squared is 4, minus 1 is 3. And now notice, -2, that gives me the order pair -2, 3. Notice it's the same as where we left off on my linear. It doesn't always work like that. This one we can see is going to be a connected graph. I'm going to go for a value right in between -2 and 2. I'm going to choose 0. So that means I have 0 squared minus 1. Well, that equals -1. So I will also have an ordered pair at 0, -1. And then I'm going to go ahead and grab that endpoint. F of 2. You will always, no matter what kind of function it is, you will want to plug in your values for the start and stop of your domain. And so that's going to be 2 squared minus 1. That's going to get me a positive 3 again. So I also have a point at 2, 3. And now if you come down here looking at the graph, well, here's our negative 2, 3. Here's my vertex at 0, negative 1. And then again, I've got that point at 2, 3, and it's filled in. And I would just, because I know that this is quadratic, it's going to be U-shaped, I just draw that in. And now let's go for that last piece. Let's take a look at where that comes from. So again, I'm going to have open dot, closed dot. This is also linear. So all I need to do is find the corresponding y values that go with the start and stop of my domain. These, remember, these are your x values. So now we're going to do f of 2 equals, and again, here's my rule, my function, x plus 1. So it is 2 plus 1 equals 3. 2, 3 is my order pair. And again, there it is. These are connected. These graphs will all be connected. And then grab the endpoint of my domain. My x value is 10. F of 10 equals 10 plus 1 equals 11. So I have an ordered pair at 10, 11, which is right here. And again, this was closed, 10, 11. And now remember too, over here, this was an open dot, and that's because the blue portion, that quadratic, was a closed dot. And then you will go ahead and just graph it. Now let's go ahead and talk about domain, range, and areas of intervals of increase and decrease. So if I am looking at the domain, domains of piecewise defined functions are pretty easy. We saw that they were all connected. So literally, if I just come back up here, my domain starts at negative 10, and that value was included, so I use a bracket, and it ends here at 10. Also a bracket. Now my range is your y values. So what is your lowest y value? Well, if you just look at your graph, your lowest y value is negative 29. And your highest y value is 11. So my y values have a range between negative 29 and a positive 11. Intervals of increase. And again, remember, when you're talking intervals of increase or decrease, you're looking at x values. You're going to be using parentheses, never ever brackets. So increasing. So if I look here, start at the bottom, I start at an x value of negative 10. And now it keeps going up and up and up and up and up. And here's this turning point. So when x is negative 2, my graph is going to change direction. But now if I come over here, remember, we're looking at a graph left to right, just like you read a book. Well, right here, my graph goes down for this little piece, but then it starts going back up again. And the x value, when it starts going back up again, is at 0. So we start off at 0, and then it keeps going up. I mean, it might be a little bit different of a graph, but notice it's never turning around. It's not really changing direction. It's still increasing. And it ends there at 10. And now let's look at decreasing intervals. So decreasing intervals, we have one area of this graph where it's decreasing. So that's right here. So what's the x value where it starts? -2. So from -2 down to an x value of 0, my function is decreasing.